guys. I wanted to fill you in on a couple terms for your light lab that's coming up. You're going to be working on a light simulation. And in the simulation, they're going to be throwing some words at you and some things that you may not have heard before. And I want to take the opportunity to talk about what's going on before you do the lab so that it might make a little more sense to you. So the first concept that we're talking about is reflection. Yes, basically you're standing in front of a mirror and you see your reflection. But light and sound and waves also have this neat component that is reflection. So here's what it looks like. Here is, and I suppose I could actually draw the sun for you. So here is a light ray coming in, and it's going to hit a mirror. We know that the mirror is going to reflect it, but can we predict where it's going to be reflected to? And the answer is, yeah, we can. So to start with this one, we first want to start off with your first word, and that is ray. So in this case, a single wave, sometimes, especially in light, we call that a ray. So this would be and the official word is incident. That means the incident, that means it's the original. So this is the incident ray. It's the ray that's coming in from the sun that's going to hit the mirror. Now, we need to be able to find out how it's going to bounce off. So incident ray comes in, hits the mirror, and it bounces off. Can we say exactly where it's going to bounce off at? Well, yes. But the first thing we need to do to figure it out is your second vocab word, and that's called a normal. A normal is a line. I'll use my little protractor here. A normal is a line that is straight up from where the ray touches the mirror. So if I'm going to draw in my normal, I am going to draw it straight up from where it hits the mirror, or basically it's perpendicular, it's at a 90-degree angle. So this is called the normal. It is a line that is perpendicular from the surface of the mirror. All right? Now, here's the fun part. We can tell exactly where the ray is going by understanding the law of reflection. And the law of reflection is really easy. The angle that it comes in equals the angle that it goes out. So if it comes in at 40, then we know it needs to go out at 40. See the 40 right here? Now, on the big numbers, it's 140, but if it comes in at 40, it goes out at 40. So it's going to go out at 40. That's all the law of reflection says. The angle that it comes in equals the angle that it goes out. This, by the way, is called the reflected ray. And the angle of incidence is equal to the angle of reflection. And we measure those angles from the normal. Quick review. Incident ray comes in, it goes out at the exact same angle. We measure that angle from the normal, so the angle going in equals the angle coming out. Anything that's a reflection works this way, guys. Even bouncing a ball off the floor, the angle that you throw it onto the floor is the angle it comes off the floor. Shooting pool, throwing a ball, basketball, basically anything that bounces is a reflection. It follows the law of reflection. That's part one. Part two is a concept called refraction. Now this object right here, this is a window. And when light passes through a window, let me draw our sun. we're going to have a ray of light come down and hit our glass. Now, the important part when we talk about refraction, do you think glass is the same speed as or slower than air? Well, we know it's going to be slower than air because glass is thicker. It slows things down, which means that when this ray comes in and hits the glass, it's going to slow down a little bit. And anybody in marching band knows that if you slow this side of the line down, what happens to the other side? It starts to turn. And that's what refraction does. It basically, and we need to draw our normal again. So let me bring up our protractor here. By the way, this is called a protractor. So we put in our protractor. Remember, that line is right where it touches. And then I need to draw in my normal. The normal is perpendicular to the surface. So now I have my normal in. What happens when this slows down? Instead of passing straight through, what we think is going to happen is if this was still air, it would go straight through. But refraction doesn't allow that to happen. What refraction allows us to do is it actually bends the wave towards the normal when it slows down. So it's actually going to go here. And then when it hits the side, it's going to go back out there. So we have an angle here and an angle here. And that's what refraction does. A good example of this would be, have you ever sat on the edge of a pool and dangled your legs over the side? Do your legs look normal or do they look kind of weird? If they look kind of weird, it's because of refraction. Now the terms again, normal. That's the line that's perpendicular to all this. Incident ray. And this one is going to be the refracted ray. All right? And the angles are going to be different. It's not the same. So this angle of incidence does not equal the angle of refraction. Every material has its own angle of refraction. So you need to know the material. In the lab, you're going to investigate this, but I wanted you to know the words in the lab before you got to it. So this should help explain everything that's going on so that you can see as you're doing the lab, it should make a little more sense to you. That's the whole goal. As always, if you have questions, don't be afraid to contact me. You guys have a great day and enjoy life.